In the previous modules, we've talked a lot about various threats and various mechanisms you can implement to mitigate those threats. Well, in this module, we're going to delve into testing. How do we test our application to see if we've appropriately handled secure programming? There's both static and dynamic application testing, which we're going to look at. In this module, we're going to introduce you to static application security testing, which includes manual code reviews and looking for the most common vulnerabilities. We're also going to look at dynamic methods, which include vulnerability scanning, proxy-based security testing tools, and similar techniques. Static application security testing. Now, in and of itself, this is probably not enough, but it is one of the elements you should do to test your code. It involves a detailed and systematic inspection of the source code. Someone who knows what they're looking for has to actually read the code. Now, you may be thinking some of your applications have hundreds of thousands of lines of code. It's not always necessary to read every line, but to read those functions which are most likely to be impacted by security decisions. Should be performed towards the end of the source code development when the application code is fairly stable. We don't want to do this early on and then just have the code change later. It won't be helpful. It's always done at least partially manually, but there are also automated methods that will at least search for specific things in your code. We're looking to detect any application security vulnerabilities and their root causes while the code is not running. A root cause analysis, basically it's also called a source to sink. It's what source or input and what vulnerable code pattern matches any particular vulnerability. This can be facilitated using data flow diagrams. You also want to find all instances of any common vulnerabilities, any things that are well known. Let's search for them. Look at the effectiveness of your existing security controls. We've talked about a lot of security controls through these modules. Do you have them effectively implemented? Look for design flaws. Are you mishandling non-user inputs? Are you properly securing server-to-server issues? After we've done all that, then we can look at uncommon security flaws, things that might be unusual, such as termination of execution flow or synchronization errors. And then we can suggest mitigation techniques to improve the code. Many serious vulnerabilities can be found just through this static analysis, and it decreases the remediation cost of vulnerabilities in later stages. We discussed early on in this course, the later you find something, the more expensive it is to fix, and that expense means both money and man-hours time. Deeper analysis is possible with less false positives and negatives. What this means is because you're manually looking at the code, you're less likely to see false positives or false negatives. Automated techniques will always have a certain degree of false positives and false negatives. This also lets you add best secure coding practices per department coding standards, so you can integrate it with your other coding standards. Perhaps you have naming conventions, for example. What skills do you need to effectively do static analysis? First of all, and we've mentioned this before, think from the attacker's perspective. If you were a bad actor looking at this code, how would you exploit it? You obviously have to have a good working knowledge of the programming language being reviewed, and the better your knowledge, the better your review. You, of course, have to know the standard secure coding techniques, which is one of the purposes of a class like this one. And you must be able to quickly detect insecure coding practices. And finally, just good general analytical skills. What are you looking for? We already said that you might not look at every line of code. So what things must you look at? Any code that's involved in authentication, authorization, session management, data validation, error handling, logging, encryption, and security configuration. You want to look at each and every one of these code elements, and these are all elements we have covered in previous modules. What vulnerabilities are you trying to identify? Well, all the common vulnerabilities. I strongly suggest you familiarize yourself with the Open Web Application Security Project Top 10 Vulnerability List, but right here we see a list of 8 items: SQL injection, cross-site scripting, authentication flaws, cryptographic flaws, buffer overflows, malicious file execution, cross-site request forgery, and sensitive information leakage. Two ways to do the static analysis. There's automated and there's manual. The manual is pretty obvious. You actually inspect the source code. The automated is sometimes called static code analysis, and it uses certain tools to scan the code and report potential flaws. Where does this fit in the system development lifecycle? Well, it can't really start not only until the development stage, but until well in the development stage. You couldn't possibly do this at the requirements or design stage. Basically, the end of development bordering on testing is where this is done. The steps. First, do an application walkthrough. Make sure you know what this application is supposed to do. Understand its functions. Talk to the developers to help determine high-risk areas, the developer's logic. Make sure you have a good relationship with the developers. The tester should not be in an antagonistic relationship with the programmers. That's going to be counterproductive throughout the entire process. Analyze threat models. Look at your existing security threats, know what you're concerned about, and define specific objectives. Now, you might say, well, I want to detect all vulnerabilities. That's unrealistic. You might do a code review for major vulnerabilities, or the OWASP top 10, or a specific vulnerability, or something of that nature, perhaps for compliance with some regulatory requirement. Define the scope. What are you looking for? What are you avoiding? How much time, effort, and budget will this require? Categorize your objectives so you start with the most severe stuff and give it the most attention. And then you conduct the analysis. Use multiple tools if you're going to use tools. Don't just use one. Make sure that the most common vulnerabilities and flaws are identified. And then you conduct a manual review. Usually the automated comes before the manual. And finally, you're able to suggest remediation practices, and oftentimes you'll be asked to prepare a written report. This flowchart will help guide you through the activities to take. You've submitted the code for review. What to look for is identified. If yes, go forward. If not, we need to go back and have some meetings. You perform your static code analysis. You record your findings. And here we can see what you're performing the analysis against. And these are options like organizational policy, standards, OWASP top 10, and secure coding guidelines. Here are some recommendations, 12 recommendations specifically, for an effective static analysis. It's not enough to say you did it, and we're not doing this just to check a box. We want to be very effective. So first of all, if possible, do it by someone other than the original programmer, a third party, a peer, an external entity. That is no disparagement upon the programmer's ability. You're a programmer. You've definitely encountered the same situation where you stare at code hour after hour. You can't find out what's wrong, and someone comes along and says, hey, you forgot a semicolon. Does that mean they're a better programmer than you? No. It means that you've looked at this code so long, you really don't see it as clearly as fresh eyes will. So if you wrote all the code, or you and your team did, and you didn't catch the vulnerabilities when you were writing it, you're probably not going to catch them reviewing it. So get someone else to do it. Make sure that someone else does understand the application architecture, the business logic, and then can look for specific security issues. Establish a clear set of objectives so we know what we're looking for in this test. Review the code for security objectives only. You're not looking for performance, business logic, whatever. That's a separate issue that someone else will look at. This is a security review. Spend time to set the clear objectives. If you don't have clear objectives, you're not going to have very good results. It's as simple as that. Make sure we prioritize so we look at the highest priority security issues first, and we address them first. Give yourself a reasonable time limit. Obviously, you don't have all the time in the world. You're trying to reach production deadlines. On the other hand, saying we'll spend 2 hours doing static analysis of 2 million lines of code is absurd. It's not going to happen. So have a realistic time limit. Don't lose track while going into detail of those higher level security vulnerabilities. In other words, you find a vulnerability and you get lost tracking down every nuance of it. Note it, document as thoroughly as you can, and move on to the next item. Always select small, manageable pieces of code to review. If you set out to say, I'm going to review 2 million lines of code, you'll be overwhelmed. Pick a subsection. I'm going to review the authentication and authorization portions of this code. Finish that task. Then I'm going to review the database connectivity portion of this code. Complete that task. Do it in chunks. This also goes hand in hand with a multi-pass approach. If more than one person gets to review the same code, there's a higher chance of it being detected, any vulnerabilities. Basically, we're all human beings. We all overlook things. And if you're depending on one single set of eyes to catch everything that's wrong, you're going to be very disappointed. Detect any secure coding mistakes that are repeatedly committed, and make sure we adjust department coding standards. If we see people repeatedly inappropriately using cookies, let's add that to coding standards so it doesn't ever happen again on future projects. What are the deliverables from this static analysis? A list of the vulnerabilities, the severity level and impact, the location, be as specific as possible, maybe a line of code or at least a function where this occurs, and recommendations to fix it. Automated source code analysis. Now you might be thinking, with large projects, I always want to use automated, and you will if you can, but also do the manual along with it. The automated takes much less time to complete, but it won't uncover every issue. They're not perfect. You're going to get false positives. You're going to get false negatives. Good automated review tools are expensive, and many of them will still require human intervention to address the false negatives and false positives. Here we're looking at a particular static code analysis tool, Checkmarks, and it's going through, it's actually giving you a little flow chart, showing you the particular function, and highlighting the vulnerable line of code. This is pretty effective and pretty useful. Here we're looking at a similar one, Visual Code Grepper. Now if you come from a Unix or C background, you're probably very familiar with the search tool grep. Well, this is a code grepper, very popular with the Unix and C world, but can also be used in .NET. It identifies insecure code. Here we're looking at HP Fortify. It's a very robust tool. Now, by the way, we're going to show you several tools. It's not our intention to endorse any of these. We're not here to promote a specific vendor, but we are showing you some of the tools out there you may want to look at and find out which one fits your situation best. Here we have AppScan Source Edition from Rational. They make a lot of other tools. Rational Rows is a common configuration management tool from them. It looks for security vulnerabilities. Selecting a tool. Well, I just showed you several of them, and there are others on the market we didn't look at. There's nothing wrong with those tools. There's just only so much time in this course to look at a few tools. How do we select the right one? Well, first of all, it has to support your programming tools. If you're doing everything in C# and you picked a tool that is designed for Java, it might not work so well. How accurate is it? Do they have statistics on false negatives and false positives? Does it also understand any libraries or frameworks you're using? A really good option is, if possible, can that tool be integrated into your integrated development environment? That'd be great if it could. It's not a deal killer if it can't, but I personally prefer it if it can. How difficult is it to set this tool up? It's not always cost. For example, it may be very inexpensive to set up a tool, but then it takes forever to get it configured. Well, that's not as cheap as it looked like, is it? Does it give you the analysis you prefer? And of course, finally, the cost. I listed cost last. I understand cost is important, but it can't be the most important issue here. Manual source code review. Much less chance of false positives and false negatives. Lots of vulnerabilities can be detected. However, it's time consuming and requires someone that really knows the code. What are the most common vulnerabilities in manual source code control? Well, in this example, we're using a specific standard, PCI DSS, and we're going to look at their requirements and search for compliance with those requirements. So here we looked at specific PCI DSS requirements 6.3.7, review of the custom code for vulnerabilities before releasing the code to production. That's actually right there in their standard, so we want to make sure we do that. Here they have a list under PCI DSS requirement 6.5 of common coding vulnerabilities: unvalidated input, broken access control, broken authentication session management, cross-site scripting, buffer overflows, injection flaws, improper error handling, insecure storage, denial of service, and insecure configuration management. These are the items they suggest you test for. Code review for blacklisting validation approach. Blacklisting: are inputs validated against known bad characters? So we're going to search the code looking to see if the blacklisting is done. Now right here, this is a really nice example. You notice it's looking at the script tag, and I talked about that in an earlier module for cross-site scripting. It's looking for SQL tags for SQL injection, and a few other related SQL injection and scripting tags. This is one way to check. We're going to see if there's places in the code where we validate. And of course, if possible, using whitelisting would be even better. Code review for client-side validation. So here we're going to check to see if the client side in the button does any validation. We can see in this case it does. We also want to check for server-side validation. Here's a code review where we're checking for non-parameterized SQL queries. We discussed in an earlier module how you should always parameterize your SQL queries. Here we're checking to see if that's not done. Same thing with non-parameterized stored procedures. Let's go see if there's any locations where they're not done. And of course, we recommend using parameterized stored procedures. We're looking specifically for cross-site scripting vulnerabilities. So do we have any output that's rendered without encoding? You'll recall in an earlier session we talked a lot about encoding. We recommend you encode all your outputs to avoid cross-site scripting. Review code for unvalidated redirects and forwards, and here we can see one right here. Each of these screens show you a specific vulnerability that you'll want to search for. Look for weak password authentication. So here we're looking, and it's a weak condition. All we're checking to see if it's null or empty. Well, that's not very good, so that's not going to work, and we always want to use strong password rules. Look for hard-coded passwords. That's an absolute no-go, should never be allowed, but we want to search to make sure it's not there. Look for any credentials being set in the clear text. Now here we can see we have a form, it's a login form, and it's going to send the password in clear text. Well, that's unacceptable. Unencrypted form authentication tickets. We can see here we have a form and the protection is none. We recommend you always set protection attribute to all. Look for any connection strings in the clear. In other words, your database connection string is in clear text that anyone could read and see exactly how to connect directly to your database. That's a terrible, terrible thing. Always encrypt your connection string. Look for the code where the developer is attempting to set passwords with a default length. Passwords should have a minimum required length that's long enough to make it hard to break. We talked a lot about that in an earlier module, but not a default specific length. Look for inappropriate authorization. Now notice here that we're looking for a pattern under authorization, and the authorization should be assigned per security requirements. Here we're just allowing all kinds of users, all kinds of roles, and we're not doing it per security requirements. Weak hashing algorithms. Here you can see they're using MD5, and there's much stronger algorithms already available to you. No reason why you shouldn't use them. Same thing with encryption. Here we can see DES being used. We already know there are stronger options. Let's use those stronger options. Not using the require SSL, and again we know that's going to be TLS today, but either way the require SSL should be set to true. Are there URL storing of session tokens? Here we can see they are using the URL to store those session tokens, and that's not allowed. And we can see it here again where we have the auto detect and the cookieless auto detect methods turned on. This is going to force session data to be stored in the URL. What about cookie persistence? Let's check to see if cookie persistence is happening because we don't want it to happen. Here we have the remember me is set to true, We also have the authentication cookie set to persist. We don't want any of that. We're continuing on with more cookie persistence. So there's more than one way to persist a cookie. We want to check all of those. And here we see the duration. 10 years? Well, that may not be a permanent cookie, but it might as well be. In 10 years, I'll have a different computer. I don't care about the cookie. So we definitely don't want that. How many failed login attempts? This is set to a large number, 8. That's way too large. 3 is the norm. You might have specific scenarios where you allow 4 or 5, but I can't conceive of a scenario where you're going to allow more than that. Providing a relative path to redirect. You can see that's being done here. And in an earlier module, we told you about using an absolute path. Code review of the server.transfer method. Never use that for when you want to redirect. If you want to redirect, use the redirect method. Review for keeping public and restricted pages in the same folder. We said you shouldn't. We said secure and sensitive pages should be in a separate folder. So here we're checking. There's only one location, so everything is obviously in that same location. Here we're seeing again an example of weak encryption. Now in this case, they're encrypting whatever is put into this link button, but they're specifically choosing DES, which we know is outdated and weak. We told you before that you're always going to use the strongest symmetric cipher possible, and whenever you can, always use the CCB mode, not the ECB mode. Here they're using ECB. Bad choice. Padding with zeros. We said you may have to pad, but don't pad with zeros. There were lots of other methods. Most interestingly, the PKCS7 padding method, which is a standardized cryptography padding method. Small key size. Now, yes, to be honest, Rindell with 128 bits probably going to be secure enough, but you could just as easily use 256-bit. Why not? Small block size. And again, we said that in general, if the algorithm is secure, the larger the block, the larger the key, the better. Now, this is probably the least important of the cryptography issues. Key size is far more important, but go ahead and use a larger block if possible. Look about keys regeneration here. We're looking to how cryptographic keys are being generated. In the first option, we can see it's being generated manually. A hard-coded key? That's a terrible idea. In the next one, we're using the standard random function. That's also a bad idea. It's better than hard-coded, but still bad. Remember, we have the random number generator crypto service provider to use. Look for any information leakage. Now here we have error handlers that are printing out the stack trace. We know that that's not okay. Here we again have the stack trace being printed out. Here we have custom errors mode set to off. We want to set it to on and have our own custom error pages that display only as much as we'd like to display. Here we can see that generic throwing of exceptions and catching, nothing specific being done. Always use throw and catch with a specific type and only have the generic as the last spot to check if nothing else caught it. Unencrypted cookies. Here we're sending cookies and we're using cookie require SSL false. We should always have that set to true. We never want to send our cookies in the clear text. Overly long sessions. These cookie timeouts are very, very long. The longer that cookie is allowed to stay persistent, the more likely it could be to be compromised. Remember the cookieless session. We want that only to be used when we've decided that we want to use it. If you're going to use cookieless session management, then make sure you've planned out how to do that and you're not going to be using URL to store session information. Regeneration of expired sessions. We want that to be true, and we explained that in an earlier module. Let's check for that. Weak session key generation mechanism. We always want to generate our session keys using the crypto service provider, nothing else. The crypto service provider is going to be random enough to be strong enough for us. Look for anything that provides vulnerabilities to client-side scripting attacks. So we have the HTTP only cookies set to true, and that means the cookies can't be read by a script. They can only be used with the HTTP protocol. View state security, we talked a lot about that. We want to make sure we're using enable view state MAC, and we want to make sure we're setting the encrypt mode. Now in this case, someone has set it to MAC to false, and the encrypt mode will also be set to not encrypt. That's a very bad idea. And here you see the encryption mode set to never. We want to make sure it's set to always and the MAC to true. Allow override attribute. You're looking for a configuration where the developer skips setting the allow override attribute in machine config. We always set the allow override to false inside the location attribute. Look for enabling the trace feature. We talked a lot about that in a previous module. We're looking for places where the developer is setting it to true or location only to false. We always want enable to false and local only to true. Look for debug features. Debug is absolutely necessary during, well, debugging. And you get a lot of information from it, but we don't want that in deployment, so make sure the debug is set to false. Look for validating request. Here it's set to false. It's always set to true. So what does a checklist contain for you? Well, we just looked at a whole lot of screens with specific items to check for, and you might have noticed every one of those items are things we discussed in a previous module. So basically, we've just told you to check for everything that we've taught you throughout this course. So make sure your checklist includes data validation and encoding controls, encryption controls, authentication and authorization controls, session management, exception handling, auditing and logging, and security configurations. Now here's just a sample list. We won't read all of it because we've discussed input validation in great detail earlier in this course, but ensure that you're checking all of these things. And this is just a sample. Feel free to add to it other items you see that might be necessary. Here's another sample checklist just for authentication. And again, this is meant to guide your thought processes. You may want to add more requirements than this in your situation. The same thing is true for the authorization sample checklist. This is just meant to get your thought processes running so you know what sort of things you need to be checking for during authorization. Session management checklist. You'll note we have a checklist for pretty much everything we've covered here. Cryptography checklist. Make sure you check for all of these items. We've seen that in this lesson on various screens. An exception handling checklist. Of course, make sure you have adequate exception handling, but then make sure that it's done right. And here's a checklist example to show you how to check for that. Logging. We talked a lot in a previous module about logging. Here's a checklist to make sure your logging is being done effectively and securely. Now, the findings from your static analysis should include vulnerabilities, architectural problems, any organizational issues, and you may include other features like, let's give a meaningful title to this report, determine the location of issues, give a detailed description. The more detailed, the better. Give a risk rating. How big a risk is this problem? We'd like to treat everything as a critical risk, but that's just not realistic, so let's rank them. And give them corrective measures. Simply saying this is wrong without saying what to do right is a bad idea. But throughout this course, we have shown you the wrong and the right, and in this module itself, we showed you screenshot after screenshot of the wrong way to do code and gave you exactly what should be done properly. The report is going to list all the vulnerabilities and details, the corrective measures to take. You might even want to use some graphical representation, some sort of graph or chart, and the control measures that you recommend for future use. And here we're seeing another example of a sample report. We're looking at SQL injection. It gives a specific location, a file name. It gives a description. It gives a recommendation, and even a reference to a Microsoft Developer Network article that explains this issue. That's really good because it's not just you should fix this because I said so. You should fix this, and here's a very reputable resource that also tells you how to fix this. Here we can see more details on what might go into a report. Particularly, you see a graph showing findings by category. You may or may not want to do a graph. Frankly, Microsoft Office makes graphs so easy, I'm not really sure why you wouldn't want to include a graph. That's static. Well, let's look at dynamic. What does that mean? Well, dynamic, you're simulating attacks. So you're dynamically testing the application when it's running. Another way to look at this is some people call static testing white box testing because you're actually looking at the code. Dynamic testing is black box testing. I can't see the code, it's just running and executing, and I want to see what happens. Now, dynamic testing is usually done after development. It's done by pen testers or security consultants in a pre-production test or even production environment. You'll use automated tools because you're going to try to bang away on this application with everything. You'll use fuzzing to input a variety of range of data to see what happens. You'll use application security scanners, proxy-based security scanners, and there's a ton of these available to you. So you can either do automated application vulnerability scanning or manual. Automated is far more common because of the breadth of things you're testing for, but you could manually try SQL injection, cookie poisoning, and things of that nature if you wanted to. And here we compare the static versus dynamic, and you can see the terms I just introduced you to, white box and black box testing. Static requires the source code, dynamic the running application. Static finds vulnerabilities earlier because we do it during the late stage of development. Dynamic is not going to find this till the end because we don't run it till the end. Static is a little less expensive to fix because we found it earlier. Dynamic, we found it later, so it's more expensive. Static has runtime and environment related issues that can't be discovered because you're running it in the code. You're not actually executing it. In dynamic, I'm actually executing it, so I might see things that emerge based on the interaction of my program with the operating system, for example. Static will support all kinds of software. Dynamic, you can get dynamic for any sort of software, but the most common tools are for web applications and web services. Here's a tool, Web Inspect, and as I said, there's a lot of these tools for web applications. It's a web application security assessment solution to thoroughly analyze web applications and web services. It's for black box testing, and you can see here, it's a very nice display. Here's the security app scan from IBM. It's meant to check, again, web application and look for common attacks. And again, as with before, we're not endorsing any particular tool, just introducing you to some of the more common ones. Here's just a list of several of them. I've used many of these. Nessus is a general vulnerability scanner. We have AppScan, that's a pretty common one. Retina Web Security Scanner has a pretty good reputation. All of these are valid choices you might want to check out. What about proxy-based security testing tools? Burp Suite is the most widely known, and it's open source and free. If you've taken the Certified Ethical Hacker course, you've certainly encountered Burp Suite before. It's used for you to try different sorts of attacks, either automated, semi-automated, or manually on a particular target website. Now, one of my favorite of the free tools is OWASP ZAP. That's Open Web Application Security Project, Z-Attack Proxy. And the reason I like it is, first of all, it's free, so it'll fit your budget. Secondly, it specifically tests for the OWASP top 10 vulnerabilities. And it's easy to use. You put in a URL, you click attack, and it goes. So there's really no excuse for still having those vulnerabilities in your web application. And here's several others out there. Vega is very similar to OWASP ZAP. Firefox Tamper Data. WebScarab, very popular in the hacking community. And guess what? If the hackers are using it on your website, you should probably use it on your website first to find the vulnerabilities before they do. Choosing between them. Well, I'm not so sure you should. It's choosing which one you do first. Both of them have their place. One is a white box, the other is black box. They each are different approaches. Using dynamic alone, you're going to have false positives and false negatives, but it's quicker and easier. Some of those tools we looked at, like Vega and WebScarab, can be run in less than an hour and you're done. However, relying on static alone doesn't mean we'll check everything. The bottom line is both static and dynamic are required to have truly secure software development. It's just a question of which you do first, what order, and how much emphasis you place on one versus another. So, in this module, we've looked at static application testing, using manual source code reviews, using tools to review source code. We've looked at dynamic, we've looked at a number of tools, and we've explicitly looked at things you want to find and correct.